To deal with this differential equation, I want to see how we can solve the general equation, the general solution of this differential equation. If you clearly see, this is a linear differential equation. How do you see it? Because you can't easily separate variables. So therefore, here we begin by dividing throughout by sin x. So dividing throughout by sin x, we shall have sin of x out of sin of x dy dx plus y out of sin of x is actually equal to sin square x out of sin of x. So this becomes dy, so we can take it to be dy by dx plus, now 1 out of sin x is actually cosec, so we shall have y cosec x and then is equal to sin x. Now this is in the form of dy by dx plus py is equal to q, whereby we can even go further and get p comparing. So our p is actually equal to cosec of x. Now after getting our p, we can go ahead and get the integrating factor, which is an exponential integral of p dx. So this tells us that this is an integrating factor is an exponential integral of cosec x dx. Cosec x dx. Now the integral of cosec x is known as the ln tan x out of 2. So therefore our integrating factor is an exponential of ln tan of x out of 2, which eventually gives us our integrating factor as tan x out of 2, because logarithm tells us that exponential to power log base is same bases, we eventually get the argument, which is tan x out of 2, and that's where we get it as this. Now when we get this integrating factor, it must be multiplied throughout. It must be multiplied throughout here. So let us multiply it throughout. So we shall have tan of x out of 2 dy by dx plus multiply it here y times tan x out of 2 times cosec x then is equal to, we multiply it the other side, tan x out of 2 times sin x. Now when we simplify this to see it clearly, simplifying it slowly, so we shall have tan of x out of 2 dy by dx plus y times, this is the same as before, so we can first write it as tan x out of 2 times 1 out of sin of x is equal to tan x out of 2 times sin x. Now let us apply some identities of trigonometry and we split. So this is tan x out of 2 dy by dx plus, now this is y, this is sin of x out of 2 out of cos of x out of 2 times 1 out of, now when you apply double half angle identity here, we shall have 2 sin of x out of 2 cos of x out of 2 is equal to, going here we shall have sin x out of 2 out of cos of x out of 2 times, apply it here still, half angle identity, we have 2 sin of x out of 2 cos x out of 2. Now we see those that can cancel. This can cancel with that. Go ahead. This can go with that. So we end up finally having tan x out of 2 dy by dx plus, now if you clearly see this cos x out of 2 times cos x out of 2, we get cos square. So we shall have y out of 2 cos square x out of 2 is equal to 2 sin square x out of 2. Yeah, sin x out of 2 times sin x out of 2, we get sin square, then the 2 is there. Now simplifying this further, we can clearly see that we are going to get a sec square x out of 2 here, and then we go ahead and simplify. So we shall have tan of x out of 2 dy by dx plus y sec square x out of 2, but there is a 2 here, is equivalent to 2 sin squared x out of 2. Yeah, so we said that whenever you solve a linear differential equation, one side becomes exact. So this eventually becomes the derivative. So where did it come from? It came from the derivative of y tan of x out of 2, which is equal to 2 sin square x out of 2. Yeah. So if you haven't seen my video about exact differential equation, I'm going to link it here such that you can see it. So cheap things. So go ahead and integrate. So integrating on both sides with respect to x, integrating on both sides with respect to x, we have y tan x out of 2 is equal to 2 integral. Now this is even powers. So even powers we substitute in accordingly. So we shall have 1 minus cos of x out of 2 dx. So why? Because we know that from sin square x out of 2 equaling to 1 minus cos x out of 2. So we substitute it accordingly. So it is from there. Now this 2 goes with this. So we shall have y tan of x out of 2 is actually equal to the integral of 1 minus cos of x dx. This tells us that we can finalize this and say y tan of x out of 2 is actually equal to x minus when you integrate a cos, you get a sine. So you have sine of x plus a c. Therefore, our final solution becomes y tan of x out of 2 is equal to x minus sine of x plus a c. Please don't forget to subscribe. If you haven't subscribed, share, because sharing is caring, like and comment. Where you have issues, we meet in the next. Thank you.